OpenAI's GPT-4 has taken the world by storm. It can generate human-quality text. It can even write different kinds of creative content. But one of the most exciting claims is its coding ability. OpenAI says GPT-4 can achieve 49% accuracy on the SV-Bench benchmark. This suggests it can solve almost half of all coding problems. Is this the dawn of AI programmers replacing humans? Not so fast. Let's take a closer look. The SV-Bench benchmark is a collection of around 3,000 coding issues. These are taken from 12 different Python repositories on GitHub. Each issue comes with tests. These tests are designed to check if the code is actually fixed. GPT-4 is supposed to generate code to solve these issues. Then, the tests check if the solutions work. This seems like a fair way to assess an AI's coding skills, right? Well, things aren't so simple. The promise of an AI that can write code for us is undeniably appealing. Imagine a world where complex software can be built with just a few prompts. This is the kind of future that OpenAI's claims about GPT-4 seem to hint at. However, before we get carried away by the hype, it's important to understand exactly what these benchmarks represent. The SV-Bench benchmark, while seemingly robust with its thousands of coding challenges, still operates within a controlled environment. It presents GPT-4 with isolated problems, stripped of the broader context that real-world software development entails. These issues, derived from GitHub repositories, are accompanied by unit tests, small automated checks that verify the correctness of individual units of code. While valuable for evaluating basic functionality, unit tests don't capture the nuances of user experience, design principles, or the integration of various components within a larger system. Researchers at York University decided to investigate OpenAI's claims. They took a deep dive into the SV-Bench benchmark and GPT-4's performance. What they found was concerning. Their research suggests that the benchmark itself is flawed. Many of the fixes that GPT-4 produced were not actually fixes at all. They were categorized as suspicious fixes. These suspicious fixes cast serious doubt on the validity of the initial 49% accuracy claim. The York University researchers didn't just point out the problem, they went a step further. They wanted to understand how widespread these suspicious fixes were. Their analysis revealed a disturbing truth. The benchmark was riddled with these misleading results. This discovery significantly undermines the narrative of GPT-4's coding prowess. It's clear that celebrating GPT-4 as a coding marvel based solely on SV-Bench results would be premature, if not entirely misleading. The researchers identified four main categories of these suspicious fixes. Solution leaks. GPT-4 sometimes used code directly from the problem description. It was like copying from the answer sheet. Incorrect fixes. The code generated by GPT-4 often didn't actually solve the problem, even though it seemed like it might. Fixes in different files. GPT-4 sometimes modified code in completely unrelated files. This shows a lack of understanding of the code base's structure. Incomplete fixes. Some solutions only address part of the problem, leaving the core issue unresolved. Imagine a student getting credit for solving a math problem by simply rewriting the question. That's essentially what GPT-4 was doing in some cases. The researchers found numerous examples of each type of suspicious fix. This wasn't just a few isolated incidents, it was a systemic problem. The sheer prevalence of these misleading results paints a very different picture of GPT-4's coding capabilities than what OpenAI's initial claims suggested. Section 5, the real price of AI coding. After adjusting for the suspicious fixes, York University estimated that GPT-4's actual performance on the SV-Bench benchmark is closer to 3.83%. That's a far cry from the claimed 49%. Even with more lenient criteria, the performance only reaches around 5 to 6%. This means that instead of solving 1 in 2 coding problems, GPT-4 is only reliably solving a handful. Using GPT-4 for coding isn't cheap either. Solving a single issue can cost around $400 considering the computational resources and API usage. With a success rate of just 3.83%, that's a hefty price tag for each correctly solved issue. This raises serious questions about the cost-effectiveness of using GPT-4 for coding tasks, especially given its limited accuracy. Section 6, why we still need human developers. The SVB benchmark, even with its flaws, highlights a crucial point. Coding is about more than just generating lines of code. It requires understanding the problem, designing a solution, writing clean and efficient code, and testing it thoroughly. It also often involves collaborating with other developers and stakeholders. GPT-4 might be able to generate code snippets, but it lacks the broader skills and knowledge that human developers possess. It can't think critically about the problem, anticipate potential issues, or come up with innovative solutions. It also can't communicate effectively with humans or work as part of a team. Human developers are still essential for tasks like defining the problem and setting clear goals, designing the overall architecture of the software, writing code that is not only functional but also readable, maintainable and scalable, testing the code rigorously to ensure it meets all requirements, debugging and fixing issues that arise, and collaborating with other developers and stakeholders. Section 7. Beyond the benchmark, the real world of software development. This brings us to a crucial limitation of the SV benchmark itself. While it provides a useful way to measure an AI's ability to generate code in a controlled setting, it doesn't accurately reflect the complexities of real-world software development. In the real world, coding is rarely about solving isolated problems. It's about understanding the needs of users, designing systems that meet those needs, and building software that is reliable, scalable, and maintainable. It's a highly collaborative and iterative process that requires a wide range of skills, both technical and non-technical. The SV benchmark, with its focus on isolated coding challenges, fails to capture these broader aspects of software engineering. Section 8. Navigating the AI hype, a balanced perspective. The hype surrounding AI, especially generative AI like GPT-4, is undeniable. However, it's crucial to approach these advancements with a healthy dose of skepticism and a balanced perspective. While AI has the potential to revolutionize many industries, including software development, it's essential to recognize its current limitations. The inflated claims about GPT-4's coding abilities, fueled by the flawed SV benchmark, illustrate the dangers of AI hype. Such hype can lead to unrealistic expectations, misguided investments, and even fear-mongering about job displacement. Instead of succumbing to the hype, we need to focus on realistic assessments by critically evaluating AI capabilities based on rigorous testing and real-world applications, addressing the ethical implications of AI, such as bias, fairness, and accountability, and developing AI tools that augment human capabilities, not replace them entirely. Section 9. The future of coding collaboration, not replacement. So does GPT-4 spell the end of human programmers? Not at all. While AI will undoubtedly transform the software development landscape, it's more likely to be a powerful tool for human developers rather than a complete replacement. Imagine a future where AI assists with tedious and repetitive tasks like code generation and bug detection. This would free up human developers to focus on higher-level tasks that require creativity, critical thinking, and problem-solving skills. This collaborative approach, where AI augments human capabilities, holds the most promise for the future of coding. It's a future where humans and AI work together to build better, more innovative, and more impactful software.